Yeah, of course. Wouldn't that change the sum? Ethan, this has been sitting on my desk for like 6 years. It's been sitting up there in the corner. Maybe you weren't here, that you passed that out. Is this everybody? So everybody's done? Turn this in. What's the answer to the bonus? Jupiter. Sure. It wasn't Pluto. Well, you could be one of those people that like just fight for Pluto. You know, that they want Pluto to still be in the game. Like, but people have pretty much dismissed Pluto as just worthless and not a planet. They don't even count it anymore. I'm gonna count it. I like it. I like Pluto. Okay, so let's talk through these next two tests. Oh, I also discovered that if I really jam this in here, it'll stick. Which kind of made me happy, but it should be like that. Okay, so we're going to talk. We were going to start off yesterday with an example, but I'm flipping that around now because we already sort of talked about it. So we're going to first talk about the direct comparison test. So both of the tests that we're learning today will require us to take a series that we know nothing about and compare it in some way to a series that we do know about. Okay? And there are two different ways that we're going to compare them. Okay? We're going to compare them using directly compare them, like decide who's bigger or who's smaller. And then the other way is with a limit. Okay? And we'll get to that when we get to it. All right, so the direct comparison is first. All right, so basically we're going to just set up the two things. We're going to say, let's let B sub n be less than A sub n. Okay? And then I'm going to say if we're not really putting this in real high-level math terminology here. We're saying if this series is always less than this one, and he converges, so does he. Okay? And then that's the first way to do it. The second way to do it is let B sub n be greater than A sub n. And we're going to say if A sub n diverges, B sub n does too. Okay, so basically the gist of this is your unknown series either has to be bigger than a known diverger, which is the second thing up there. And if that's true, your unknown series diverges. Or your unknown series has to be smaller than a known converger. And that's the first one up there. Okay? That's how that works. If you say that you're less than a known diverger, that doesn't really tell you anything. You might still diverge or you might converge. You don't know. Okay? And similarly, if you say that you're greater than a known converger, that doesn't really tell you anything because you still might converge or you still might diverge. All right? So let's look at a couple examples of these, just sort of how it looks. So I'm going to give you this series right here, 1 over 2n squared plus 1. I'm not real happy with that sigma, but we're going to keep it. Okay? So what series are we going to compare this to? That's what we have to decide. All right? You have to decide, what am I going to compare this to directly? So where you start with this is you sort of start with, what does this kind of look like? It looks like a p-series, right? So which p-series does it kind of look like? 1 over n squared. So let's compare this with 1 over n squared. So now I'll go ahead and write this. We won't write this every time. So now the thing that we have to determine is 1 over 2n squared plus 1 less than 1 over n squared? We have to answer that question. Okay? And I'll be honest with you. If you can't answer the question easily, then you probably need to pick a different series to compare with, or use a different test. Okay? You don't want to spend minutes and minutes and minutes trying to decide this. Okay? This question can be answered fairly easily. Okay? Because they both have the same numerator, right? And this denominator is always going to be bigger than this denominator. Right? So if this denominator is bigger than this denominator, what does it say about this fraction compared to this fraction? It's smaller. Game, set, match. Okay? So we say yes. So then we'll say this converges by the direct comparison test, which I will just abbreviate DCT. Okay? Let's look at another one. Oh, I guess I got to give this a. Why did I have to start that at 2? Yeah, with the 0 in the denominator, right? So that would be a major foul. Okay, so what do you think? What does this look kind of like? 1 over into the 1/2 or 1 over radical n? Are we cool with that? So we'll do a compare with. Why is this a squeaker? And what does this guy do? He's a diverger because he's a p-series with p equaling 1/2. Okay, so the question is, so since this is what Maddie chose to compare with, what we really need to show then is that this guy is what compared to this guy? Bigger. Is that true? Now, you don't just want to write this down and not verify it, but is that true? Is 1 over the square root of n minus 1 bigger than 1 over radical n? It is, because the denominator is actually smaller. Okay? So, yes. So this guy diverges by the DCT. Let's try one more. What do we want to compare with? Is that what you were going to say?
Yeah.
Or were you going to say 2/3 city and that? That's the same thing, right? So that's a geo? Is that a converger or a diverger? I think that was on your quiz. He's a converger. So we got to show that this is less than this. Is that true? The answer is yeah, because that denominator is always bigger. So the fraction is smaller. So yes. So he's a converger by the DCT. Okay? So I can tell you, the difficult part about the direct comparison test is sometimes figuring out if it's actually smaller or bigger. And if you have to spend too much time doing that, it's probably not worth doing that test. Just do the limit comparison test. Because it's much easier. You don't have to play that game. Okay? Which you're like, wait, but I don't know the limit comparison test. Well, you're about to. Okay? So questions on that? Are we happy with that? Does that seem pretty legit? But you got to have some known convergers and some known divergers in your pocket, right? And you got to know the P rules. And you got to know the geo rules. Those are probably the most popular ones to use. All right, so let's go limit comparison test. I like this one better. This is probably my second favorite test of all. The ratio. But we haven't learned that yet. The limit comparison test. So again, we're going to have a known series and an unknown series. So suppose we know that one. Right? The limit comparison test says this. You're going to compute this limit. You're going to compute that limit. Okay? And actually, you can flip it. It doesn't matter. You can put B in on top and A in on bottom. It doesn't matter which one you put on top. Okay? You're going to compute that limit. And you're going to say that equals whatever. If this limit is finite and positive. If that limit is finite and positive. So not negative and not infinite. Then both series do the same thing. Okay, again, we're not using real high-level math terminology here when we're teaching these tests. Both series do the same thing. Like, it doesn't really sense. You wouldn't see that written in a math book, probably. Either they both converge or they both diverge. Okay? And this is the test. That is essentially the test that allows us to do the reducing rule. Remember when we were talking about that the other day? Or the test that basically says if it looks like P and smells like P, it's P. I mean, you're going to treat it like P. Okay, that's what this is. So let's look at these examples just to see how that works. So we'll start off with an easy one. So n over n squared plus 1. Now you might see here, like, if I was going to try to do a direct comparison test, it might be difficult to determine bigger and smaller. Like with the n in the numerator, it's just, I don't know if I want to mess with that. But we can look at this, and we'll do a limit comparison test by saying, okay, what is that one reduced to? What's that series reduced to? Like, I'm using reduce, like, not really reducing, because that's, but if you really sucked at algebra and you didn't know what you were doing and you just started canceling stuff, what is that going to end up being? 1 over n, right? So now we're going to do, and what does 1 over n do? Divergence. So now we're going to do the limit comparison test. So we'll do LCT with 1 over n. So we're going to do this. We're going to do the limit as n goes to infinity of 1 over n over n squared plus 1. And after you do some algebra, when you simplify this fraction here, you're going to get n squared plus 1 over n squared. If You multiply by the reciprocal. And what's the answer to that limit? What is it? 1. I heard 1. Like, actually, it wasn't that high. 1. Okay. Now, remember how we've said multiple times, like, oh man, when you're taking a limit, you got to know why you're taking it and then what the answer means. Okay. And what can we conclude from the answer? Okay. What's the conclusion here? They both do the same thing, and since we knew 1 over n diverged, the unknown one diverged. Okay? Now, what does it really mean? Okay? What does it really mean? What does the 1 mean? I mean, the conclusion is that it diverges. What does that 1 actually mean?
It's like the n-term test, it's not 0, it diverges.
Okay, you're going back to the conclusion, and what you said is correct. But what does the 1 actually mean? If I were to say that 1 means this, what does it actually mean?
Because eventually you'll just keep adding 1.
That's if it were the nth term test, but we're not looking at one series here.
The terms are approaching 1? No?
Not the terms are approaching 1. What's approaching 1 here? And you actually don't, in this particular question, you don't really need to know the answer to this to be able to make the right conclusion. But I still want you to understand what that 1 is. That 1 is basically saying the ratio of the terms from the known and the unknown is approaching 1. That's what it's saying. Now, we really don't need to know that to make the right conclusion. Okay? But what you don't want to do is confuse conclusions. You follow what I'm saying? Like, because in the nth term test, if you get 1, that means the series diverges. In this test, if you get 1, it could mean it diverges, it could mean it converges. It depends on the series that you were starting with. All right? But this is finite, this is positive, so this guy converges by the LCT. Oh, thank you. No, you're right, it does. Because 1 over n, he's a diverger. Diverges. All right, let's do another one. Hillary Field. Yeah.
You'll never get the limit of the n over bn equals 0.
Oh, that's a good question. What happens if you get 0 here? Test fails. Can't do it. You can't do anything. Because 0 is not finite and positive. Okay? So if you get 0 when you do that test, you're SOL. All right?
You have to do another test.
You got to do another test. Yeah. Okay, here we go. How about 2 to the n over 3 to the n minus 1? Just slightly different than the last one. Because the last one's 3 to the n plus 1, which we can easily say that one was smaller than the known converger. This is actually bigger than 2/3 to the n, because the denominator is smaller. So we could just do the limit comparison test. We'll still do 2/3 to the n, or 2/3 to the n. But we'll just do this, so we don't have to worry about who's bigger, who's smaller. 2 to the n over 3 to the n over 2 to the n over 3 to the n minus 1. So this ends up being 3 to the n minus 1 over 3 to the n. And what's that limit? That's when we haven't done one like that probably in a while. Is that top heavy, bottom heavy, or balanced? It's balanced. What are the coefficients? The coefficients are actually 1. So that's balanced. So what's the limit? 1 over 1. Okay. Now, if you don't believe that, let's just knock out a L'Hopital real fast so you can see. What's the derivative of the top? Well, the derivative of the top would be 3 to the n times natural log of n. I'm sorry, natural log of 3. And what's the derivative of the bottom? 3 to the n times natural log of 3. So when that cancels, that equals 1. Okay. So what's our conclusion? This one converges by the limit comparison test. Yep. Happy with that? All right, let's do another one. So basically, the question is always going to come up, how do I know what to compare to? You start off by picking the thing that the series looks most like, or what it reduces to, quote unquote. Okay? That's where you start. And that's going to work 90% of the time. And chances are, if it doesn't work, it's easier. It'll be easier to do a different test. Okay? Are the terms going to 0 in that series? As n gets huge, what are the terms approaching? Well, as n gets huge, that's approaching 0. The cosine of 0 is 1. 1 minus 1 is 0. Oh, so there. Okay, now this one, you don't necessarily you can't say what it looks like. You've never seen anything like that before, right? I haven't seen anything like that before in here so far. So then it's like, okay, well, let's just pick a series that we know that's easy to work with. See what happens. What's the series that you know that's easy to work with? 1 over n squared, that's easy to work with. And what do you know that one does? Converges, okay? I think there's a simpler one to start with, and that's 1 over n. Okay? So I'm going to, just because it's a simpler series, all right? So I'm going to start with 1 over n. I'm going to do the LCT with 1 over n. So here we go. The limit as n goes to infinity of 1 over n over 1 minus cosine of 1 over n. And now this one's going to be a little tough because we got to do L'Hopital's rule here, friends. Okay? What's the derivative? Well, by the way, we have 0 over 0 here. What's the derivative of the top? That's the antiderivative of the top. It's negative 1 over n squared. And what's the derivative of the bottom? The derivative of the bottom is going to be sine of 1 over n times negative 1 over n squared. Yes? Cool on that? Okay. So what happens to these one? Ooh, what happens to those 1 over n squares? They cancel? We'll have to finish that one. Or finish it tomorrow. So here's our sheet for those two tests. Again, you probably want to do these on a separate piece of paper. It's not very much room to cram all that in. All right, peace be with you.
They're a little hot. This is the first time I haven't been cold. Yeah. Hey, Mary, is the bonus for 2 or 1? This should be worth 2. This should be worth 2. Yeah.
Because you got it right.
Yeah. Who is everyone else that got it right?
Did you get everything else right? That's all I care about.
I think so.
I don't know how you care more about the books.
I forgot the last. Are we doing a quiz or? I know. Yeah, we can work on it.
Quiz first. Yeah. I don't know. I don't know.
Okay. Thanks.
Yeah. Yeah, I don't know. That's a tough one.
I'll ask him for a sec. Yeah, because they can't miss.
Guess who's going to work?
What?
Guess who's going to work?
Not even
They're
that.
going about the music. So have fun.
Huh? I can ask Tuesday.
I have to go lifting today.
Oh, fun.
Because they changed the time that it starts, so now I really don't have an excuse not to go.
When does it start?
It starts at 3:15.
Oh.
And I have to leave by 3:45. So when it started at 3:30, I'm not gonna go for 15 minutes.
Yeah.
And now it's a half hour.
No, you can go.
Yeah, I'm gonna go for 30 minutes and then go straight to practice. So. Yeah. Fun.
Oh, sunscreen is a good one. Sunscreen is a good one. I'm putting 10 on sunscreen.
Oh, Lordy.
I think it's sleep. I think it's sleep.
Ooh, I might put 10 on sleep too.
Oh, that's your best.
I think we already had a sleep.
Now that I think about it.
Let's take a quiz. Meow. Huh?
I'm so excited.
I'm so
You know that song? Who sings it? That's your bonus question.
No.
Don't we get 2 bonus questions today?
Yeah, we do.
That's the last time.
That's what you said last time.
Wait, yeah. You did say that.
Last period, I gave them one question that was worth 2 points.
You can give us 2 questions.
So you have 4 problems, and then number 5 says find the sum of the series from above that converges, which basically tells you, that only one of them at the top converges, right? So let's see, bonus. Of the 9 planets, okay, we'll include Pluto in this. Well, actually, we won't. Let's just say of the 8. Okay, of the 8 planets, which one has the shortest day? Meaning, which one takes the longest to make one rotation on its own axis?
Longest
I'm sorry, the longest. I didn't say longest. Yeah, sorry, the longest. Which one has the longest day? Which one takes the longest to make one rotation on its axis? I better double check my answer. 90% sure about this.
We have to put what test we use.
Yeah, state the test used.
Oh, I know where you do it.
Yeah, well, that explains a lot. Was right. Talk to me. Sure. Yes. Okay. That'll work. I think. finished?
Yep, I think so.
You finished? Sandy Will. No. You also spelled that wrong. I know I did. I don't know how to spell. Uranus. Oh, well, I just told you guys a minute.
Was mine right?
No.
Oh.
Oh, dear.
Yeah, what you do? Just go around the room.
Is mine right?
No. You put what she put.
No, it's fine.
What? No, she didn't. But you don't have to do it.
Which one has
Sure.
2 moons? Jupiter has like 6.
Jupiter has the most moons. That was their last period question.
I did a project on Jupiter when I was in like 5th grade.
Europa, that's one of the big ones.
That's all I remember.
Io, Europa.
No, Ganymede was the smaller one. Yeah, Jupiter's your.
My very elderly mother just shot up the North Pole. Isn't that how you remember the planets when you were?
No.
No, I don't.
It's like my very excellent mother just brought us 9 pizzas.
Oh, okay.
That's what I was taught.
I just remember. I just not really mindful of it.
Wow.
You know what?
Yeah, if you're guessing, the time that you spend
Oh,
on deciding on what to guess doesn't matter, right? Nope.
Don't Google it.
Why
It's
not?
more fun to tell you.
And then you're gonna kick yourself when you hit the answer.
Okay, no, I'm getting one.
For a birthday. Or maybe that So, okay, yeah, you have a couple more minutes here, friends. Are you just trying to figure out the answer to the bonus? Again, if you're guessing,
It's a plan that.
how much
nobody
time?
would think of.
Well, there's only, well, we're down to 7 options here.
Oh, yes, down to 7.
Since we threw Pluto out, and I don't know if you heard me say that Uranus was not right. Uranus. I'm not sure the appropriate pronunciation.
Well, I don't get it. They all of them pronunciation for it. Because it's not like, who would be a regular body on this? I think Uranus is the scientific.
Yeah.
What are you gonna do with that?
And then you always think of the other one. Because vending machines and stuff.
You're rich.
Thank you. Isn't Uranus one of like a really backwards thing or whatever?
Sure.
Why not?
Well, because I know one of the planets is backwards thing. Then they
Samuel, I am convinced that you know more than everyone in this room. one knows that, except for you.
I agree with
He's
that.
asking a question, and he really doesn't.
Well, unless it's about math, I might be able to.
Maybe. But like, when you ask a question, no.
Are you seriously writing them all and then ruling them out? Oh, Billy. Give me your clues.
I choose.
Oh, you crossed out the wrong one.
It was Venus. Saturn.
Actually, it wasn't
Saturn.
Mercury. Mars.
Oh, then it's Venus. Dang it.
Are you done?
Oh, wait, it's still saying it.
Oh, you put Mercury. I can't believe no one yet. It's funny that you're all guessing, and there were like 10 of you. No one get it.
It's Venus.
It's Venus.
That was my second.
And you actually could maybe reason to that if you know something about the climate on these. What's Venus?
Why would I know?
Venus's climate is like horrendous. It's like hot all the time and like cloudy.
The cold one.
Huh? Venus isn't cold.
Oh, yeah, I remember that from the took that trip to last year.
No, you did not.
Said he took that terrible, you know what? All the actual, this episode only lasted like a maximum of 2 hours.
And Mercury's like spinning around like a top. I mean, that thing's like, I think it's super fast. No.
Is it Venus that has the backward spin? I think one of the planets has a backward spin because another planet hit it.
All right, so we're gonna learn 2 more tests today. So the test that we're gonna learn today, we call the comparison test. And the comparison tests basically involve taking an unknown series that you don't know anything about and comparing it in some way to one that you do know about. Okay? And we're going to teach you 2 different ways to compare them. The first way that we're going to compare them is literally just see which one's bigger or which one's smaller. The other way we're going to compare them is with calculating a limit. Okay? So let's jump into this. So the first one is the direct comparison test. Okay? So I'm going to say this first statement here, let's let B sub n be less than A sub n. If now we're not using real formal math language here. So we've got 2 series, a known one and an unknown one. Okay? And what I'm saying here is that our unknown series is less than a known converger. That's what this is saying here. Our unknown series is less than a known converger. And the conclusion that we're going to draw from that is our unknown has to converge. Now think about that just for a second to make sure we can wrap our head around that. If you can show that an unknown series is less than a finite series, a series that converges, it would make sense that the unknown would have to be, if you're less than something that's finite, you have to be finite. Right? The flip side of that is let our unknown series be greater than our known series. And if we can show, oh, that's embarrassing. If we can show that our unknown is greater than a known diverger, then we diverge. Okay? So if your unknown series is less than a known converger, he converges. And if your unknown series is greater than a known diverger, he diverges. Okay? What does not work is if you show that a series is less than a known diverger. You're saying, oh, this is less than something that's infinite. That doesn't tell you anything. It still could be infinite. Okay? It also doesn't work to say that it's greater than a known converger. Oh, this is greater than something that converges. That doesn't tell you anything, because it still could be convergent. It still also might diverge, right? So this is what we call the direct comparison test. So let's look at a couple examples of this. First one would be these. One over 2 n squared. So the problem that that we all have, essentially, when we're dealing with these comparison tests, the first problem that we have is, what do we compare to? And then the second problem that we often have is, how do I show this is greater than or less than? Okay? So to answer the first problem, how do we know what to compare to? Well, I'm looking at that series 1 over 2 n squared plus 1, and I'm going to say, basically, what does it look most like? 1 over n squared. Okay? Start there. What's it look most like? Right? So I'm going to do a direct comparison, which I abbreviate as DCT, with 1 over n squared. Test. So I'm going to ask myself this question. What does 1 over n squared do, by the way? That converges because he's a p-series. Okay? So I'm going to say, is 1 over 2 n squared plus 1 less than 1 over n squared? Is that true? Okay? Is that true? Now, if you understand how algebra works and how numbers work, you might be able to answer that question really easily. Because you're comparing two fractions, basically, right? The numerators are the same. The denominator of the first one is actually bigger than the denominator of the second one. Okay, for various values of n, this is bigger than this. Which means that the actual fraction is going to be smaller. So the answer to this question is, yes, it is less than, isn't it? And because I just showed that that is less than something that I know converges, our conclusion is this guy converges by the DCT. Okay? Yeah.
So, if you couldn't tell just by looking at that, this one's fairly easy. I feel like the other you couldn't tell. Would you just multiply each or bring each one to the power or minus the power, then switch the right to n squared plus 1 is greater than n squared?
Well, maybe. I'm going to go out and kind of say that if you can't make the comparison relatively easily, then use a different test. Because the limit comparison test, which we're going to learn here in a minute, is way easier to do because you don't have to know who's bigger and who's smaller. Okay? I would only use this direct comparison test if it's relatively obvious in the comparison. Okay? All right, so what does this guy look like? 1 over radical n. So we'll do a comparison with 1 over radical n. So I have to ask myself this question. What does 1 over radical n do first? It diverges. So is this guy greater than that? Is 1 over radical n minus 1 greater than 1 over radical n? And if you compare the denominators again, the denominator on the left is smaller, which means that the resulting fraction is bigger. So the answer to this is yes. So he diverges by the dct. Okay, let's do one more here. Guys, I'm getting a little lazy here. So what does he look like? What do you think, Alex?
2/3 to the power.
2/3 to the n, the geo. And what does he do? It's a conversion, right?
Yep.
So we'll do a comparison with 2/3 to the n. So I have to ask myself this question. Is that true? If this is true, then I can conclude that that guy converges. Is that true? Is this less than that? Yup. So this guy converges by the direct comparison test. Oh, you're right. It's not, because I wrote down the wrong problem. Now it is. Yeah. You're right. But it turns out that if it was -1, it's going to converge also. We would use it, and that's a perfect example of where it might be difficult to come up with something that come to like directly compare it to. So instead, we would use the limit comparison test and still use 2/3 to the n. The limit comparison test takes out of play the whole like who's bigger, who's smaller. It doesn't matter. Okay. So that's a good transition. So let's learn that one. The limit comparison test. Limit comparison test. This is my second favorite test out of all of them. My favorite one is the ratio test, which that'll be the last one, which is coming. Maybe Thursday. Okay, you ready? So here we go. The limit comparison test says, suppose we know one of the series. Okay, remember, these are always comparing one with we know and one with we don't know. And we don't know this one. So what we're going to do is we're going to compute this limit. Okay? We're going to compute that limit. And it actually doesn't matter which one you put on top. Okay, I put the known one on top, but it doesn't matter. Let's say the answer to that is L. If this limit is finite and positive, both series will do the same thing. Okay? They either both converge or they both diverge. Okay, finite and positive. All right? Now, let's do some problems with this. This is the one that basically allows us to do the what the series reduces to and kind of do that trick. All right. So what do I mean by that? Like if you remember, we had a one like this a day or two ago. So what is that if I were to say reduces to? Like if I really sucked at algebra and I just started canceling stuff left and right, what am I going to end up with here? 1 over n, right? Now technically it doesn't reduce to 1 over n, but reduces to, okay? So what I'm going to do then is I'm going to do the limit comparison test with 1 over n. So how do I do that? I go like this. I do the limit as n goes to infinity of 1 over n over 2n squared plus 1. Okay? And then I compute this limit. Now I got to have on my algebra pants here, because I end up with 2n squared plus 1 over n squared. Because I multiply by the reciprocal. Yeah. Plus 2. Sorry, that's a stupid. Might have been 1 last period. That's why I did that. It was. Okay? And what's the answer to that limit? When I do this, I get 2. Okay? Now, I've said this, I've preached on this several times, but it's really important that we know why we're taking the limit, like what limit we're taking, what the answer means, and the conclusion that we can draw. Okay? In this particular case, what is the conclusion that we can draw from that and that number being 2, that limit being 2? Is 2 finite and positive? Yes. So what does it mean? Both the series do the same thing. And we started with 1 over n, which diverged. So this diverges, the unknown series here, by the limit comparison test. Okay? Now, just out of curiosity, what does the 2 mean? What does the 2 mean? And it turns out that what the 2 means isn't necessarily going to help us come to the right conclusion, but I still think it's a good exercise for you to think about what that 2 actually means. It's funny, no one was able to answer this question correctly last period when I asked them this. They all knew how to conclude that 2 meant they both diverged, but when I asked them what the 2 meant, they weren't sure. What limit is it? What are you taking? when you take that limit? What limit is it that you're finding? Aaron, you think you know? What? Oh, you're still thinking. I thought you were putting your hand up. What's that 2 mean? You're finding a limit, but you put those things on top of each other. Alex, what do you think?
This is just an educated guess, but does this mean that 1 over n reaches infinity twice as fast as n over 2n squared plus 2?
Yes. It's moving. The terms are, yes. But that's not how I would have, I didn't think of it that way, but yes. And because 1 over n is going to infinity, it reaches infinity twice as fast. You actually even took it one step further than I was thinking. I was just thinking that the ratio of the terms of this one to this one was equal to 2. That's what that says. And then you took that one step further and said, what does that actually mean? Well, I know 1 over n is going to infinity, and it's going to infinity twice as fast. You sort of like peeked into why the limit comparison test works. If you think about it. That's why, because they both do the same thing. Well, I knew, because that limit was 2, and because 1 over n is going to infinity, it's going there twice as fast. If 1 over n converged, it would be converging twice as fast as the other. Does that make sense? Like, wow, that's well done. So this class is smarter than last class. That's the conclusion. Yeah.
Wouldn't the term approach ratio of 1 over?
Yes, the ratio of the terms is approaching. Yeah. All right, let's do another one of these babies. Well, I don't think I have one, so let's use this one. Oh, I didn't. Well, hold on. Well, we'll go ahead and do this one. So this one we might be kind of like, yeah, I don't know what to do, because what is this one like reduced to? Well, it doesn't, right? It doesn't reduce necessarily to anything, okay? So in order to use these comparison tests, you got to have some convergers and some divergers kind of in your pocket to use. Okay, P series are really nice to work. 1 over n is nice to use. Okay. Are the terms going to 0 for this? Like, do we even have to do anything? Does the nth term test work here? What happened to the terms as n goes to infinity of that series? As n goes to infinity, what does this do? That goes to 0. What's the cosine of 0? 1. What's 1 minus 1? 0. Oh, so the terms are going to 0. That didn't help me. So we got to do a limit comparison test. What's something that you might want to use? And just pick one. Pick a series that you know what it does. That's easy to work with. 1 over n? I'm gonna try 1 over n. Okay, let's try 1 over n. See what happens. So we're gonna do an LCT with 1 over n. So we're gonna compute this limit. Right? So if I go to infinity here, now I've got 0 over 0. So that we got to use L'Hopital's rule here. So what's the derivative of the top? Someone last period said natural log of n. Oopsie. It's the antiderivative. Derivative of the top is negative 1 over n squared. What's the derivative of the bottom? Well, derivative of 1 is 0. Derivative of negative cosine of 1 over n is sine of 1 over n times negative 1 over n squared. Chain rule. Now what happened to these 1 over n squareds? These cancel, right? So now I'm left with this. So what is that approaching? 1 over n we know is approaching 0. And the sine of 0 is 0. So this is approaching 1 over 0, which is infinity. What does that mean? Can I use this test? This test won't work. At least this test won't work with 1 over n. Follow what I'm saying there? Because that didn't pan out. We needed something that was finite and positive, right? That's infinite. So we would have to use a different series to compare with. Yeah.
Why do you do 1 over n minus n cosine 1 over n?
What?
Or like distribute the 1 over n to the bottom instead of doing the L'Hopital rule. And then you just have like n minus n cosine 1 over n, which is like 1 over that. Well.
But you still got infinity?
Yeah.
Oh, well okay, yes, that didn't help me though.
Yeah.
I don't know, I think L'Hopital's rule is pretty easy to do. But here, I guess I'm gonna have to give you these for now. We'll have to figure this one out tomorrow, I guess. More than likely, what I'm gonna do, my friends, is I'm gonna make a video of me working out these problems. And I'll post that tomorrow. You think? But this is your homework tonight? Yeah. But we got to figure out. We still need to answer this one.
Yeah.
Oh yes, that's still going to be not bad.
Yeah.
Yeah. Yeah. It still doesn't work. That's the problem.
Yeah, but
Harvard, Oxford,
Get ready.